All right, looks like we're now recording. All right, so welcome to week 5. I hope to hear much more from you, Crichton, soon. I see your first attempt at the first IP finally came through and needs a lot of help. I gave you some feedback in the attached feedback file for Word so that you could have something with which to base it on. All right, before I get into too much of this, this week, we're going to be going over imported, extracted, transferred data, target location. So basically taking it from source to destination and how to do that, how you pull it, what the how you should handle it within SQL via SQL inserts or bulk inserts, and how to perform file integrity checking. The integrity checking is necessary to ensure that your source data is valid, in order to accomplish what your ultimate destination file is about. So, or destination data is about. Quick reminder, everything in blue is considered late. I will accept it from you only because the mention of previous issues that you emailed me about, but I'm still going to apply the tardiness penalty to most of it. The stuff in yellow is what's due or was due this last week. Stuff in green is due this week. In order to get your Unit 4 up to date, you're going to need to do a lot of work. So go back, check that feedback, but I do expect all the individual projects to be improving upon each other. So it's a growing project as you go. The end goal of this class is probably a 20 to 25 page project in the end. Okay, so keep that in mind. That is your ultimate goal if you want to, with all 5 of the pieces added. Week 4 discussion board is going to be about posting your own key assignment outline to discuss, or you're able to, so we can review your plan, right? In this case, I want you to put your outline out there so that I can give you feedback on it, which then will help you in the process of building out your paper that for the individual projects as well. So, and in this particular assignment, please include 2 different APA references in order to complete the necessary pieces of this assignment. And therefore, I would also see the posting to then be incorporated into your individual project in the process, right? So this is going to be about how to get what kinds of rules, how will you walk through the process of transforming data from source to destination, and what is necessary to get that accomplished. So, so the video and reading content for the week is going to on Muse for week 4. I'm going to flip over to the video of it now to play the video.
Cleaning up after yourself as a developer is a good habit to get into, no matter which stage of the extraction, transformation, and loading process you're in. In the data loading stage, it becomes perhaps even more important. Data that are not cleaned up, especially for larger projects, can eat up a good deal of storage space. The last part of the load portion of the ETL process is the cleansing of test data, usually in the form of clearing out the temporary database table. Many of the processes within the ETL process can be done with a combination of scripting language and stored procedures. This allows many benefits, such as encapsulation of business logic, reducing traffic, and application modularization. These benefits can amount to great savings for a business in any stage of its growth. Encapsulation of business logic is an important concept for the ETL process and many others. Separating out business logic from programming logic allows for specialization of skill sets. That way, programmers can focus on being programmers and not on being an expert in what the company does. This streamlines the process and makes overall development faster, makes more efficient use of resources, and ultimately saves time and money. Reducing traffic on the server makes both public-facing sites and inward-facing sites more efficient. Users are more apt to return, and the use of the services grows. This can reduce a company's overall bottom line by making the automated services more used and potentially cutting down on labor hours spent. Application modularization enables application construction with pieces that can be used over and over again, which is the goal of object-oriented programming. A stable, dynamic, Robust and reusable application is the goal of any programming department, and the ETL process is no different. Loading the data is an important part of the ETL process and requires a firm attention to detail.
Yeah, so making sure the data makes sense, it's there, it's consistent, it's loaded in memory quickly, it's well organized so that it's faster to process it. It's faster to load into memory, faster to be used by individual users. Like I said, the ability for a website to be efficient is why people use it. If you think about it, right? If Google or Amazon was inefficient and took 20 seconds for every search to find what you're looking for, how fast would it be till somebody went and found an alternative, right? That they are built for optimized speed and optimized searching. So their ability to use metadata on the back end in order to find topics and then to find the actual thing you're looking for rather rapidly is part of how the searching um, uh, ETL process for them, how that actually works well for that, so that it encourages users to come back because they can find what they want, get it done, process every transaction quickly, and they feel good about how they did what they're accomplishing. So, all right, I'm going to go back over the individual project from the top, so that based on the feedback I gave you, you have a better idea where you're going with this. So, your title page was generally good. Table of contents, I didn't really look so much, but it looked like it could be a format of the auto-generated contents. It should be on its own page. APA says you should only record 3 levels deep and not any further. So that is a configuration aspect of the table of contents. Each section is approximately 4 pages of contents above and beyond the title page, the table of contents page, and any references pages. So from ETL requirements and analysis, not just the 4 layers, but also how you intend to accomplish, what are the requirements you're trying to meet, which is part of what's in the individual project itself. Then week 2 is going to be about the data extraction procedure, how you're going to get the data from the source, what sources are you using, the process by which you're acquiring the data, what formats you're using, the JSON, XML. The week 3 is going to be about the transformation, where you convert it to the data you need. The data loading procedure, this is going to be this week's portion of it, which is going to be how you get it in the memory, how you get it loaded into and processed quickly, and feature warehouse scenarios is going to be the last week. So remember, at a certain point, you're going to need to write actual SQL statements into this, and that's going to be part of your paper. So here's how you can get to the software in order to help you accomplish that. So week 1, address the general enterprise environment. So basically explaining what the company does, how it's being used, and what is its business goals. Just saying a company is large does not meet the description of what it is, because that has to tell me, all right, what kind of business is it in? What kind of data center does it use? What is it tending to record? What's its business goals? Is it not just making money, but it also has to process user data? Does that need to deal with privacy? So what is the overall environment that you're working within? Okay. Describing the data that needs to be processed. So that's what it is you need to grab, where you're grabbing it from, what it is you're trying to record, and go from there. Then you got to describe the 4 layers, what the 4 layers is used for, and ideally how it's going to be actually used within this design. Then you got to analyze the different layers and how their specific goals are within the system, and then create. I also want to see a data flow diagram added as part of this paper, so that I get an idea of what it is, where you're going, so that I can tell where it is you're coming and where you're going. Now, in the individual project, in order to be successful, these kinds of questions are what needs to be answered, right? It's important to make sure that you are feeding your online transaction processing, that can be broken up into multiple categories, right? So that we can understand where you're going with your code, so that I can see where your SQL is headed, and I can give you advice on how to get there. So your goal is to get these questions answered as part of the first 4 to 5 pages for the week of week 1. The diagram in this case helps to define where it is you're going, where it is you're heading. So if you look up things like conceptual framework or business data flow, or use Google to search up those 2 terms, or maybe brainstorming fishbone, that gives you an idea of what the graphic should probably look like. That'll give you an understanding how you get from a logical data flow, or how you come up with the pieces that go into a logical data flow. So hope that helps, but it will also give you an ability to help you break down how you get from point A to point B, based on what pseudocode you're going to end up writing in the process, or the SQL statement you're going to put together. So the week 2 set will be about creating the dummy sets of data. So 4 different formats with 10 records each that covers some combination of all of these particular data pieces in various types, so that you can use them to then build the SQL statements in order to extract the data from your source and put it into a consistent end state data file. So if you have like 4 different sources, 4 different formats, one's XML, one's JSON, whatever, maybe a flat file, you say, all right, this is how you read the last name, how you read the last name here, how you read this last name, how you get first name, last name, fill in the addresses. These are mapping from this source to this destination. These all go in to build out your table, a normalized reference table, or rational database. All right. Sorry, not rational, relational database. Yeah, I used to spend many times being a database tool guy for a rational Apex development environment. So a relational database behind everything. So then you can create the SQL statements then that go with each of those records, so that you can figure out how to extract the data from the source, put it into that destination, and explaining this process, pseudocode, and potentially the SQL statements themselves as well. So successful in this thing is defined as creating output from inputs. So how do you consider to get this stuff? Creating the files in such a manner to extract and parse the data as need be to get it there. So you need to get your SQL table or your destination relational database that stores the final results from where you're coming from these sources. So types of connection strings to be used. So these are the kind of questions I would need to be able to get answered. Something along these lines, right? So is it reusable? Was it built in a modular, object-oriented manner? Can I reuse the code in various things? Is it easy to adapt? Is it something that was clean and easily extracted the data from, and understood and how it was accomplishing the goal? So, sorry. Yeah, so that's why you break this up in there. Generally, if you follow a good structural breakdown on a flowchart, for instance, you can figure out how you want to accomplish those tasks in pretty quickly in a very straightforward manner. But like I said, this should be about 4 pages of writing as well that describes this process. When it comes to SQL statements, it's okay to use a different font type, so that it stands out from the rest of your writing. So say, for instance, use say Times New Roman or Calibri for your writing as your default text font in your paper. Then it's okay to use like Courier New or System Fixed for SQL statements. Okay, so that it stands out differently. The week 3 assignment is about how to create 5 specific data validation rules. So how you actually prove that your data is good and valid, and corrects it if it's not. So if you intentionally had bad data fed in from one of your sources as part of week 2, this would be able to validate and fix errors so that you can, in the end, know that everything is consistent. So describing the process and how it's done, describing how you do transformation, include a couple of screenshots if possible to as additional pictures within this paper. So create the list there, clean the data by filtering it, tell me where it's rejected, where it's accepted, transforming data to a usable format. So it's all in the different places into everything goes into one format in the end. Make sure you do your parser and profiler. Make sure the results all end up in a database, a relational database table, or a flat file that looks like a table. Execute transformation to verify the data is clean, and repeat the process until you have everything correct. So if you built a decent set of SQL statements, describing the process on how to do this is where I'm looking for. If you can do it with SQL statements, that's even more better, or a more an approved answer in the process. But the idea is to be able to tell me how you actually got from source, how you extracted it, how you modified it, how you filtered it, and then you recorded it using your SQL statements. So what rules used, how to get processed, how do you focus on the data, where is it coming from, where is it going, that kind of stuff. So these kind of questions are what I'm expecting to get answered in about 4 to 5 pages worth of writing. So, and additionally, how you do cleanup, because making lots of garbage files in the end is problematic. But in quality engineering, the ability to reuse your tools and properly clean up so you don't leave garbage behind, so that you're not wasting unnecessary resources, improves everybody's life. So it's not just for your own usage, it's also for others, right? So lots of cases, developers, especially software developers, have a tendency to want to waste extraneous data in a development environment. It could be because they want to keep testing information. It could be because they want to keep test files. It could be because they just have extra pieces of code that they're putting in places that they just want to keep around for whatever reason. Or maybe they want to have their last 10 executables stored after they compiled and run, because they just feel the need to have to back up everything on their own above and beyond what the infrastructure is actually backing up for them. So that's why in the business world or enterprise world, we actually put quotas on how much space individual users are allowed to have, so that we can force them to have to do regular cleanup, because a lot of people just don't. But in the world of programming, you need to be really good at that, because you don't want your random data to or trash data to be populating your operations site either, because that also takes up wastes a lot of extraneous space. Developers tend to grow their size up to the point where they always meet the quota. No matter how big or small that quota is, they always find ways to beat it. So be careful about that. All right, so the week 4 portion of this, I want you to describe specific steps include some screenshots and the rationale you use to load the process and transport it from the source and destination until you get there. The point would be is how you loading it quickly so that it's used and processed and validated as need be by SQL quickly. So this is more of a show me how you do the loading process and making it quick with all the SQL statements, so that we can build so in theory you would be able to build a report very, very rapidly, or populate something very rapidly. So proper connections of a database, proper setup of a SQL query strings, how to inspect it, proper destruction of used resources, so the proper cleanup process. So make sure things are done efficiently within the SQL statements, or at least describing the process by which how to do that, right? Even if you don't have the exact SQL statements to get all it done, at least if you describe how you use SQL to make that happen, that would be useful. And then the last week will just be about how to reuse this for future data warehousing needs. So how do you take the work that you've done in this project, and how does it apply against these other things for future purposes? So, and the expectations of that part of the assignment too, for those couple of pages. Remember, each week is roughly 4 to 5 pages of writing, above and beyond the reference table and the table contents on the front page. So in the end, I'm expecting around 20 to 25 total pages of the project by the end of IP number 5. So now, how do you convert the data? So with the database, you have to load the database into a temporary table. So that is a matter of basically starting up your whatever it is to host the database and bringing it in so that's in memory. So you say load, see in Access, you say load this data file, right, or data table file. In things like Oracle, it's like, all right, you've load this table. In SQL, the SQL load statement that points to the source of the information. That all brings it into memory. So then you have to transform it by processing it with statements saying read from this source, output to this source, and if need be, a bunch of different statements like that for the purpose of bringing it in and loading it and sending it to the right destination. So it's a matter of going through the process of turning data into information and making it useful for people to use. So okay, so at the end of the load statement, you should be able to create a database that can be visible in one or more formats. Could be text, could be JSON, could be JavaScript, doesn't matter. The engine that runs the loading process is typically a scripting language with the information coming from a database. So those would be what brings it into memory so that it can be easily viewed, deleted, or modified. That's the intent of the loading process, right? Bring information from the background, bring it from its sources, put it in memory so it can be easily manipulated. You have to consider how it's being done. You have to also figure out what you're doing with test data. How is it being loaded? How do you know it's correctly loaded? What does it look like? What's the field look like? How would you modify it before you commit permanent commits, or i.e. you make actual save changes that modify the source data for good? In case you need to roll back, how do you do rollbacks? Is something to take into consideration when it comes to database management as well, or SQL programming, or how to do backouts of commits. You have to also ensure your backups never get damaged or modified as part of the loading or transformation process, because you don't want to damage or dirty your source data. So you also need to consider how often you do regular backups. It's very possible that in many cases, the database, if you need to, like at Amazon, that stuff gets backed up and transaction recorded into logs for processing every time a transaction takes place, right? But if a company was doing work with Amazon and selling their goods there, and they lost a day's worth of sales, that would be an impossible thing to recover for many cases, and a day's downtime could be the end of a business, right? It could be that much money lost, revenue lost, that they literally go out of business because of even one day's worth of downtime. So business critical backups or mission essential, mission critical type systems, you need to have those available at all times, and you need to be able to roll in databases. You have to roll transaction logs so that in the event that something does get corrupted, you can go back to a known point in time and then push all the post processing of those transactions into the database to make all the modifications you need. So you need to make sure that the frequency of the backup frequency is done in a predictable and intentional manner, and avoid in order to keep things up to date and thing, right? So cleansing the database can be done with a combination of scripting languages and stored data. So as we learned in the last voting cycle, some people failed to clean up the voting test data that took place in the New York City's governor's race, right? Well, there's some several thousand, 100,000 extra votes were tallied because they failed to clean out the test data. Well, that was kind of embarrassing for everybody there, but there was something they were able to figure out what caused the issues, and they were able to solve. However, it's still an embarrassment for the person who was doing the database that they failed to do proper cleanup of their data sources and their data destination, and to get rid of test data before they actually did work. So you don't want to be that person. You want to do stuff and not catch the ire of people of accidentally making your destination data dirty. You have to also ensure accuracy within data. So you have to go through the process to make sure not only does it back it up correctly, but that the correct amount of data is being backed up. What is it doing? How is it clean? Um, do you know when it's out of date? Do you know how to determine if it's out of date? So, and can you remove anything that's useless or obsolete at that point? Typically, the process required for loading is to upload data to the server, clean up old data, commit transactions to the database. So that's your typical extraction transformation process as part of this. Now, in this context, you need to make sure you write your pseudocode or your SQL statements that will guide you through the process of upload, test, commit, and archive. So each of those are defined functions that a database manager or database administrator needs to ensure that their capability and their toolkit is able to handle. And you have to make sure that your data is also, properly committed, properly changed. So you archive anything obsolete. You always clean up after the data loading phase because poorly cleaned up spaces waste large amounts of space. They can result in tests being accidental dirty data being added into a database or test data being in a database. They can it helps support the encapsulation of data in business logic supported by scripting languages. You want to reduce network traffic. You also want to reduce database resource utilization. There's a number of reasons why you want to make sure it's clean processing, right? From a network standpoint, we have high enough networks now. It's not like you're going to cause in modern data centers, you're not going to cause a bottleneck on processing traffic by loading, unless you're like bringing it over long distance WAN or something. But if you're working within a data center, you'll have access to 32 gigabit fiber channel protocol type connections or terabit style data center networking cores, or even 10 gig or 100 gig networking backbones that a lot of times are used in older data centers. But all of those give you the ability to process stuff and move data around efficiently and quickly. So it's not only to be able to move it quickly, the thing is also be able to handle it in an efficient manner, right? So I'm a big fan of like highly dense, large compute resource blade chassis that's being used instead of rack mounted servers, because everything is done in the back plane of a blade chassis for not only movement of information around, but also the processing and sharing of resources. It reduces strains on networks. It reduces strains on fiber channel, on other aspects of a computer data center, right? But it does have the downside in that sometimes those blade centers are actually slower in the sharing of information between servers, albeit they have a shared memory, shared pool of resources from memory. So anything done in memory is available to all the systems at the same time. If your program is, if your apps are written to be able to handle virtualization well. But if you have, if you're not using a virtualization layer and you're actually installing bare metal onto a blade chassis, and say one's your database server, one's your processing server, one's your logic server, one's your ETL server, at least they would have access to shared resources within the same box and the same backplane and the same internal networking connections, as opposed to having to go out and across multiple network hops in order to come back, adding various delays and or additional gates to there. Because every time you make a network hop, it can be anywhere from 5 to 15 milliseconds of delayed traffic and processing. And in some cases, that actually matters for mission critical type activities. So make sure you clean up yourself as a developer, get into the habit of always clean environments processing data. Make sure you always blow away all your temporary data. Make sure you always set to 0 or delete your temporary data, basically, right? So make sure you always process it clean, especially for larger projects, because wasted space is important. Wasted resources on the infrastructure can be costly to an environment. And we can, I've seen lots of places where they took like, oh, we'll buy a 200 terabyte storage array that should be able to last us for forever for what we do. We're only going to be building some apps and whatnot, right? And then 2 years later, because developers find ways to waste space. They find unique ways to waste space. That same group is going back to looking to have to spend this another couple $100,000 on getting another couple 100 TB of raw data storage capacity because nobody knew how to clean up the data correctly in order to make efficient use of the environment that they already had. So make sure you do what's necessary in order to be clean your test data, clean your temporary data. Don't store extraneous unwanted stuff inside of your system. All right, parsing data is an act of uploading the data to the data warehouse. Throw true and false questions now. So right, that is false. Parsing is the act of figuring out how to extract the data to insert into tables or variables that will store the data in a structured manner. Question number 2. Every table in database should have a foreign key. That is false. A typical table has a combination or one or more columns that contain data that can be uniquely identified. Those are called primary keys. That's what's necessary, is having primary keys. They're the ones that let you identify how every database can be filtered and sorted out. A foreign key is typically some combination of one or more columns that can establish and force a link between multiple databases, but not necessarily, or tables, but not necessarily used to be as a primary. It's there to do referential integrity, so that if one table references another table, then that table foreign key must always exist in order to make those two links possible, because otherwise you could lose the integrity of a rational database or relational database to be able to be referenced across systems, right? So that's where foreign keys come in. But not every database needs one, because if you need to have a standalone single database or a standalone single relational database or table, then you don't need foreign keys, because they're only there to get multiple tables to be able to control data between each other. Referential integrity is important to enforcing data integrity with table and database. True, foreign keys are necessary for referential integrity, because, like I said, you have to have them. That one table refers to another table in one column to this column, from column A to column B. Then you have to make sure that the destination always exists, right? If you break that destination, then you basically break the ability for those two to be interlinked. Database fields should enforce type safety. Not necessarily. Type safety discourages or prevents type errors. Type errors is experienced undesirable behaviors and discrepancies. So basically having the wrong kind of value in a particular field. You want to make sure your data is good, but the database itself shouldn't really care. The source of the data shouldn't care. It's the processing front end that cares, so that you don't want the database to actually deal with it, because it's a waste of processing data when it has to go there and figure out if it itself is always correct. And having a database constantly do that just is a waste of resources. So instead, you build good type safety up front, so that your data entries are correctly transformed and written into the database, such that they're always consistent and they're always good data once they're in the database. And that's why you use an ETL process to get that started with, right? You want your front end validation to ensure that your data being put into the database is good, so that you don't have to worry about this. Question number 5: normalization in a database will reduce or eliminate data redundancy and dependency. That's true. So good normalization allows you to have as small of tables using up as minimal resources as possible, and increases the ability to actually be efficient in loading and be in processing. So getting rid of extraneous duplicated lines matters greatly in this context. Both the fields in a table and the scripting language can enforce data parsing rules. True. Data normalization processes help to reduce issues with the data at a later date. So having good front-end processing and parsing ensures that the source data goes into the destination data table is well built. So yeah, you want good data normalization. And usually that is a skill of itself that a lot of database architects go through early on in order to ensure that they have what they need and then properly built into the process. All right, that is the that is the discussion for the day. Please email me if you have questions. I hope you do catch this and see where this will help you greatly in your project, Crichton. I hope you make some serious strides in the next week or so. Remember, we are down to our last like 14 days or less in this class, so you have a short period of time left to get the work done. All right. With that in mind, email if you have questions, and I hope you do well. Thanks. All right. Bye.